Hello everybody, this is going to be our first online lecture. So we are going to today discuss about inverse function. So to find out which functions are basically we can do inverse of those function, we need to learn the definition of one-to-one function. So let us see what is one-to-one function. So for one-to-one function, we are going to try to learn one-to-one function using a graphical method called horizontal line test. So horizontal line test. Horizontal line test. All right. So we are going to choose three different function, and we are going to plot those three function, and we are going to basically try to find out which functions are one-to-one function and which functions are not. So let us first start with a function of x. Function of x equals 2x plus 5. 2x plus 5. So if I try to plot this function, I'm going to try to plot it. So this is my x-axis and this is my y-axis, and the function is going to look like something like that. So this is my function a. So let us now look at function b. Now my function b is let's say it's a function gx. Function gx equals x square minus 1. And if I try to plot this function, so this function is going to look like something like that. So this is my x-axis and this is my y-axis, and it is going to be a parabola shifted downward by 1 unit. So this is a parabola shifted downward by 1 unit. All right, so now let's look at the third function, function c. So function c, let's say I have another function hx, and function hx is defined by 2 square root of x. Okay, now if I try to plot this function, it is going to look like, so this is my x-axis and this is my y-axis, and my function is going to look like something like that. Okay, so this is basically plot of my all the three function. Now to use horizontal line test, I am going to use basically I'm going to draw actually lots of horizontal lines. So let us try to draw horizontal line for all three functions. So let's say for the first function I'm drawing some horizontal line. For the second function I'm going also drawing horizontal line, and for the third function also I'm drawing several horizontal line. Now our next step is, let's look my each horizontal line for the first function intersected only at one point with my graph of my function. For the second function, each horizontal line intersected at more than one point. So each horizontal line intersected my graph at more than one point. For the third one, each horizontal line intersected at only one point. So my first function is basically one-to-one function. So this is called one-to-one function. Now the second function, as the second function intercepted more than one point, this is not an one-to-one function. Okay, so this is not an one-to-one function. And the third function is also a one-to-one function, so this is pretty obvious. So even though all the three functions are function, but not all functions are one-to-one function. Now why we try to learn one-to-one function? Because inverse of a function, I can find inverse of a function only if that function is a one-to-one function. So what is the conclusion I can write? I can write that, so I'm going to write down that conclusion here, that inverse of a function is possible. So inverse of a function is possible if and only if the function is one-to-one. If the function is an one-to-one function, then one-to-one function. So this is basically the criteria to find inverse of a function. So now we are going to move to find the definition of an inverse function. So how to so what is the definition of inverse? So let us see. So definition of inverse function. So definition of inverse function. First of all, let's say I have a given function of x. So I have a given function y equals function of x, and remember this function of x must be or must need to be an one-to-one function. So this is given. Now how a inverse function is denoted. So inverse of a function is denoted by, so inverse of a function is denoted by a symbol. I'm going to write down in another color using a f and superscript -1. Okay, so that's how we basically denote a inverse of a function. Now so let's regroup. So given y equals function of x, the inverse of a function, which is function f superscript -1. So inverse of a function f superscript -1 inverse y is going to be equal to x if and only if, so if and only if y equals function of x. So this is the definition. So let me box it around. So what did I say? I says given y equals function of x, the inverse, so f inverse y is going to be equal to x. So this is the definition. Now let us try to see this definition using a graph. Okay, so what I am going to do is I'm going to try to use an graph paper to try to understand this inverse of a function. So what I am going to do first is I am going to draw two function, okay, any two function. Okay, so let us see, I'm going to draw a function starting from here. I'm going to draw a function starting from here, and it is going to go like that. So this is my one function, and I am going to draw another function. Let's use another color for that function. I'm going to draw another function. Let's say, of course, it's starting from here, but it is okay. So I draw two functions. So now let us see. So now we see, so the first function, let's say this function is denoted by function of x, function of x. So this function is denoted by function of x equals half x. So this is the function. Okay, I choose any function. Okay, so don't worry about why I choose function of x equal half x. It doesn't matter. It doesn't matter. Let's say the other function, is basically other function. I'm just putting any name. Okay, it doesn't matter what name I put. So I'm saying that the other function is equal 2x. Okay, so I have one function which is function of x equals half x, and I already plotted that function, and I have another function which is equals 2x. I also plotted that particular function. Now let us see basically what we got. So let's say for the first function, let me use another color. So for the first function, let's pick a point x equal to. Okay, so I am picking a point x equal to 2. So what I am picking for the which function I am choosing? I am choosing function of x equals half x, and remember this is what equals y. So what I choose? I choose x equals 2. So now let's see, if I go x equal 2 and I hit the function, and I am going, and what is my y? I got y equals 1. So I got y equals 1. So I got y equals 1. So what I got? Y equals 1 for x equals 2. So what I can write? I can write 1 y equal 1 equals what? Function of 2. Okay, function of x. So I basically essentially what I did, this is what y equals function of x. So y is my 1 and function of x, and x equal 2, so function of 2. So I basically got 1 equals function of 2 for my the first function. Okay, so let us do with another color. So let me choose another color. Now let us see, I'm going to flip x and y. Now I am going to try to see this time y equal to 2. So I'm going to choose y equal to 2 for my second function. So if I choose y equal to 2 for my second function, and I hit the second function, and I go down, and what I found x equal to 1. So I found x equal to 1. So now what can I write? So I can see that that for the second function, which is y equals 2, so it is 2 equals function inverse x equals 1. So now if you compare the two equation I have written before. So what I have written before, if y equals function of x, then definition of inverse function is what? Function inverse y is going to be x. That is by definition. Okay, so now let us use this conclusion using our graph. So what I found 1, which is y, 1 equal function of 2. So y equal function of x. So what I can write now, so this is my, so let me connect it with this. So in this case, my y equals 1 here and x equals 2 here. So what I got x equals 2 here and equal to 1. So function inverse, this is actually 1. I should write down that equal to 1. So now let us use another example. So let's do another example. If function 3 equals 5, find what will be f inverse 5. And the second example is if function inverse -1 equals 7, then I need to find what is function of 7. So these are my problem statements. So now let us try to use our theory. So in this case, 5 is my y and 3 is my x. So what I have, y equals function of x. So y equals function of x. So what can I write? Function inverse y equals x. So I can write function inverse y. So this is my function inverse y is going to be equal to x, and in this case x is what? Equal to 3. So that's the answer. For the second problem, what I have function inverse -1 equals 7. So in this case, my x is 7 and -1 is my y. So what I was given? I was given that function inverse y equals x. So what can I write? Function of x. So I can write function of x equals y. So y equal actually -1. So this is basically the definition of inverse function. So in the next video, we are going to try to learn some properties of inverse function and then some example. Okay, so see you.